Hi, Professor. This is a video presentation of Group 7. The theme of our project is Game of Life. Our main content will consist of 4 parts. First, an introduction to the project. Then we will show you how to implement Game of Life in 3 different programming languages. Next is to simulate the forest fair based on the principles of Game of Life. Finally, a summary of our project. Game of Life is a cellular automaton invented by John Horton Conway in 1970. It has simple rules and is a simulation method with great potential for application in modeling. We apply this classic cellular automaton to solve the practical problem of forest fires. Forest fires are extremely destructive, and the rapid spread of fires is one of the main reasons why it is difficult to control them. Considering the weather, vegetation, terrain, and other factors, the fire rescue work also faces great challenges. Therefore, in order to better understand the spread behavior of forest fires and predict the spread path of fire, we apply the principles of Game of Life to the field of forest fires. The main contribution of our project is the construction of a forest fire prediction model based on adjustable rules and probabilities. This allows users to simulate fire conditions in different simulations in different situations according to specific needs. In addition, we have adopted Python to improve Python performance using the Matplotlib and Seaborn libraries to visual simulation results and provide data analysis capabilities. This is conducive for users to analyze the trend of forest fires and summarize the key characteristic for forest fire spread.
Hi, my name is Yu Jiagu and my ID number is 21012746. Now is our part 2 of implementation of Game of Life in Java, C++, and Python. And now let me introduce our Java program. There are 2 Java classes in this program. The Live Game class is used to display the contents of the window and to provide functionality for buttons. And the World class is used to specify the evolution rules of the cells and the corresponding function of the buttons. Now let me show you our running results. Here's the game. In this game, you can choose the random mode to generate the random shape of cells and press start button to start the game. And you can pause the game and continue. And you can change its speed to faster mode and hyper mode. It can let you see the result faster. And here's also an add mode and kill mode for you to create the start shape of the cells in the world. In add mode, you can add cells to the world, and kill mode to remove cells from this world. And you can start the evolution. And in this part, in help, you can see the whole rules of Game of Life, and about is about the creator's name and ID.
Hello, I'm responsible for the C++ code implementation of the Game of Life. The game is represented on a 2-dimensional grid of cells. Each cell can be in one of 2 states, alive or dead. Every cell interacts with its 8 neighbors. By using the OpenCV library, we mainly achieve 5 parts of the function. Number 1, generate initial cell population. You can generate an initial cell population with random distribution, or you can set the initial living cells by clicking the mouse. Number 2, update cell states. Update the next state of each cell according to the state of the current cell and the state of each neighboring cells. Number 3, clear cell population. You can clear the current cell population and generate a new cell population. Number 4, draw the cell population. Draw the current cell population status on the screen. Number 5, interactive control through keyboard import to control the game start, pause, clear, and other operations. Next, how it works. The game displays a grid where each cell can be alive or dead. By default, the grid is empty. The user has several interactive options. Press R randomly populates the grid. Press Enter proceed to the next generation. Press Z automatically updates the grid every 0.5 seconds. Press C clear the grid, and so on. Then I will show how it works in project. I will show in two modes. The first, I will manually add some cells. Then I will press Z to simulate it. Well, I press C to clear the screen, and the second mode, I will press R to randomly generate some cells. And we can see the life of the cells. Well, that's a simple demo of my project. Thank you for watching.
The passing implementation in part 1, and we have write two Python file. The first one is the main Python. It's a visual implementation of the game of life. And in this file, we cite the game parameters and initialize the PyGame window and other interface element. And the game evolves by constantly looping over and updating the state of the game board. The next one is the board Python. The board class is the core part of the game of life, and it used to manage the state and evolution of the board. Now, let me show you how it works. And look at the menu items. The first one means we create a new world. And in this new world, we can set the position of the initial cells in the world, add and delete new cells. The next item means we can pause and continue the life evolution process. This one means it creates new cells randomly, and we can also use this button to slow down and this button to increase the speed of life evolution. And in this way, we can observe the evolution process step by step.
My name is Haosen Zhang, and I do the presentation of part 3, Python implementation. Okay, first of all, I'm gonna introduce you the 4 files in this project. The first file is class tree, includes the state of each tree in the forest, like whether it's on fire or whether it's dead or it's normal. And the second file is grid forest, is a core class file, includes a method of rules, and I implemented the core functions in this file. And in the main.py, we import the file above to simulate the forest fire. And the last one is setup.py, which is using language C to accelerate the whole project. And here is a picture you can see, which is generated by Matplotlib. When you're running this project, you can see the fire is spreading during the times. The red dot is burning tree, and the green dot represents dead trees, and the green dot means the tree is normal. And we apply the rules in each loop. We generate a curves graph to show the relationship between 3 values to visualize how the data is changing. And in the end, we will generate a heat map after 100 times loop, which can show the whole forest situation and calculate the numbers of trees state. it's easier for us to analyze the data.
Now let's turn to the part 4. The part 4 mainly focuses on the future work and conclusion. First, let's talk about the future work. Of course, there are still some shortcomings in the project, and we will try our best to improve them in the future. They are mainly focused on the 2 areas. The first one, due to the complexity of fire propagation, simulation parameter tuning can be performed. For the parameters of fire propagation, for example, probability of burning and probability of tree growth, more in-depth research and tuning are performed to more accurately simulate the real situation. This can involve domain knowledge in fire science to better reflect the real situation. Another one is due to the variety of fire environments, many different types of trees can be added, each with different growth rates, burning probabilities, and other characteristics. This allows for a richer and more varied simulation. This improvement improves the maintainability and extensibility of the code and making it closer to a realistic simulation.
In general, we recreated the game of life in 3 programming languages. We also improved the game by adding the ability to draw the initial state of the cells, change colors, adjust the speed, and so on. At the same time, we expanded the Python version of Game of Life by introducing adjustable roles and probabilities, visualizing tree states and fire spread trends. In the future, we will consider the influence of more external factors and use real forest fire data to optimize our model parameters. Thank you for listening. That's all our presentation.